absolutely fascinating, and understanding them is essential to your understanding of calculus. We're going to look at 3 different methods of finding limits in general, and specifically in this unit. We are going to look at the analytical method of finding limits, and by analytical, all I mean is that we're going to use algebra or calculus. Some people would call this kind of the mathematical common sense method. My pen is off, and that's kind of strange. This is common sense, or pretty much we're going to use a lot of algebra to solve these. The second method is the numeric, and here you're going to make a chart of values, and you're going to watch what happens as the numbers get very close to the point you're looking at. And then graphical. The third method you're going to use is graphical, where you will put them on a calculator. Now, when I took calculus 105 years ago, we didn't really do much graphical because calculators couldn't do them, actually. And we were lucky they could add, subtract, multiply, and divide. But now the calculators have these wonderful capabilities to do graphing, and we will explore a good bit of that. A good chunk of the AP test is using your graphing calculators. Now, let's look at this problem right here. What happens as x approaches a specific value? This is always something we're looking at. Let me change my pen color here. Now, I want to do this analytically. I want to use algebra or calculus to find the limit as x approaches 2 of x minus 2 divided by x squared minus x minus 2. Now, one thing, whenever you have these polynomial things, you kind of always have to figure out, do I have any common factors in the numerator and denominator? Specifically, you need to look at the denominator and make sure you don't have any zeros. So I'm going to come down here and I'm going to rewrite it. You always kind of rewrite things. You're always very neat, aren't you? This is the limit as x approaches 2 of x minus 2. Now I'm going to factor this denominator out. You remember factoring from pre-cal? I want two numbers that multiply to be negative 2 and add to be negative 1. Now, of course, minus 2 and plus 1 multiply to be negative 2. Now, do they add to be negative 1, negative 2 plus 1? Yes, indeed. Now, if I look at this, I will see these two terms here can appear to divide themselves out. So we're really looking at the limit as x goes to 2. I'm sorry this is taking a while. I don't know what the delay is, of 1 divided by x plus 1. And you see there are no discontinuities at this point. We're looking not at the value when x equals 2, but what happens in the limiting process as it goes toward. When we do it graphically, it'll make a little bit more sense what I'm saying here. But at this point in time, you can see I can simply plug in the 2 into my x value, and this is 1 divided by 2 plus 1, or 1/3. Now, let's just write this as 0.333. Remember, you always want to take things to 3 decimal places. You can truncate or you can round. Mathematically, I want you to round. Now, I want you to do this problem. Analytically solve the limit as x goes to 3 of 1 over x plus 1 minus 1/4 divided by x minus 3. Now you're going to need to do a little bit of algebra in the numerator because this is a fraction itself. All right? When you're done, go on. Now, numerically is when you take a table of values. For this one, I started at 1.9 and then went to 1.99 and then to 1.999. That's going from left to right, so that's approaching 2. All right, this is 2 in the middle, so it's approaching 2 from the left. So when I plug in 1.9, 1.99, and 1.999, I am quite literally plugging it into this x minus 2. So this is, I'm not going to do each and every one of these because this is tedious, divided by 1.9 squared minus 1.9 minus 2. So everywhere you have an x, you put in the 1.9. When you do that, you get 3. About 0.3448. When you do this for each one of the terms, going to the left, you can see it goes to 0.3448, 0.3344, 0.334. So it's getting smaller towards, it looks like about 0.33. Well, if we go from right to left, this direction, when I put 2.1 in, I get 0.3226. And these go, as you can see, they also go down. Excuse me, these actually go up to where they get closer to, what, 0.333. So you could approximate the limit, and just give me an approximate, 0.333. And why do I say that? Well, because to 3 decimals, these now agree. So you just keep making the spacings closer and closer, the closer you get to this value of 2. I guess a 2 should have been up here. You can see you're getting closer and closer to an answer of about 0.333. So that's how you can numerically approximate any limit. However, it's kind of tedious, isn't it? Now, your turn. Stop the tape and fill this out. And yes, this is the same problem you had before. Now, this is the same problem I did before. And in this case, I'm putting it in a calculator. And you can see when I put in into the calculator x minus 2 divided by x squared minus x minus 2, then I get some interesting answers. First of all, let's look up here. You see I'm very meticulous with my parentheses. Calculators are stupid and they're very unforgiving if you forget a parentheses. I have to use the caret even though I don't like it. Never, ever, ever, ever write that on your paper. Always use the square notation. Do not use this calculator notation. The calculator is stupid. You are not. And make sure you include your parentheses. Now look at this graph. First of all, you'll see that the calculator doesn't always give you a good answer. The calculator doesn't know what to do at this point right here. All right, at this point right here, it's actually at x is equal to -1. The calculator kind of has a fit, and so it just draws this kind of random line because it really doesn't know what to do. It turns out the function's undefined at that point. But we're not worried about x is -1, we're worried about x equals 2 right here. So at x equals 2, you can graphically come in, and lo and behold, if you were to put this on your calculator and not have a weird pen that's just totally messing up on you, you would see you could blow this up on your calculator screen. And let's see, as we didn't do our increments close enough here for us to get a really good answer here because this is not being very helpful. But you could graphically come over and read off. Now you see this isn't necessarily very accurate either unless you use some of the functions of your calculator. Your calculator can actually read the values as you get closer. Now, this one right here is interesting, and I wanted to show it to you because look at this right here. The formula is x cubed minus 1 divided by x minus 1. Now, do you see at x equal 1? It's not undefined. I mean, as a matter of fact, the calculator is lying to you. The calculator is saying everything's fine, and everything is not fine at that point right there. So you really need to be careful. This is a parabola, or it's a parabolic shape. You have to be really careful when you put stuff in your calculators, because your calculator again is stupid. It doesn't know how to interpret everything. So just be careful that you analyze any problem whenever you're analyzing it graphically, that you also analyze it analytically and make sure you're not putting in values that don't exist. Now, graphically solve this one. Put this in on your calculator and make sure you put in all your parentheses. As a matter of fact, I'm going to give you a hint. You probably need to add another set of parentheses right there. Okay, so this whole thing goes together. Subtract. And then I'm going to put another bracket in there for you in another color if my pen will switch. All right. Is it switching? Yeah, here you go. So you want those right there. And then you want a set on the bottom. Okay. Apparently we're not showing color. Oh, there it is. Whoa, that was unpleasant. Erase that. There we go. You want the last set to be right down here. Oh my, I have no idea why my pen is being so weird. But tell you what, let me just erase all my parentheses. When you put it in your calculator, you want the denominator by itself, so you know you're going to have parentheses here. And you're going to want this term all together, subtract it from this term, and then that whole thing grouped. It's probably a better way to put it. All right. Okay. Turn the tape off. Finish this. And I want you to sketch what you see in your in the screen of your calculator. Okay. When you're done, finish your homework.